Welcome to True Projects. In this video, we are going to explain about the project that is exploring the intersection of big data and AI with CRM through descriptive, network, and contextual methods. So, before getting into the execution, first let us understand what is this project about. Think of customer relationship management or that is CRM as a way of business to really understand their customers. So, CRM is nothing but it is customer relationship management. In the past, it was mostly just a system to store customer information like names, contact details, or past purchases. But now it is much smarter. So, with the help of artificial intelligence and big data, CRM can do a lot more. It can look at huge amount of information to figure out the customer habits, like what they are likely to buy, when they might make a purchase, or what products they prefer. It can even give personalized suggestions to customers, almost like a personal shopping assistant. So basically, modern CRM it helps companies not just to keep track of customers, but actually understand them better, predict their needs, and also build stronger relationships over time. So these days, businesses are collecting more and more customer data than ever before. Lots of different types of information and at a really fast pace. They're collecting lots of information that do at really fast pace. So the problem is that traditional methods and old algorithms struggle to keep up with the huge amount of data. They can be slow, have trouble scaling to handle all the information, and sometimes don't give very accurate insights. So, because of this, companies now need smarter ways to manage and analyze data. They need tools that can quickly process large data sets and still cover meaningful patterns. So, to overcome with all these issues, this project it combines the big data and artificial intelligence to study the documents related to customer management and figure out what areas they belong. And here, to get the data, that is to get the right documents, it uses a trusted source called Web of Science and it selects the most relevant ones carefully using structured process called Prisma framework. Once all the documents are gathered, the system analyzes them to find patterns and connections, basically looking for hidden relationships or the trends in the information. This helps businesses or researchers understand the data better and make smarter decisions. So, to do that, first, it cleans up the data, that is, it cleans up the documents and organizes them so they are easier to work with. And this means removing common unimportant words and looking at the basic details of the each document. So, in the next stage, here we use something called network methods to see how different words are connected. It even creates the word clouds, which are visual tools that show the most important or frequently used words in a way that is easy to understand at the glance. So, finally, the system goes a step deeper. It uses advanced methods to find patterns and topics within the documents. So basically, it is figuring out what the documents are really about and what themes tie them together. This helps to uncover insights that aren't immediately obvious just by reading the text. So here we are incorporating the stochastic neighbor embedding, that is SNE clustering technique, non-negative matrix factorization, that is NMF, and topic modeling to identify the deeper context and the root topics within the document. So after analyzing the document, the system uses smart computer programs called machine learning models. So here it uses the machine learning models that are support vector machine decision trees. They are like the tools that learn from examples to make accurate decisions. So these are incorporated to predict which research area a document belongs to. And the system is built on a platform called Apache Spark. So all the models are trained, I mean, the data will be loaded through Apache Spark, and all the models are built on this. So this makes it faster and able to handle lot of data at once. To make sure that it works well, the system is tested using standard measures that check how accurate the reliable predictions are. So, in simple terms, this means the system doesn't just make guesses, it gives trustworthy results that can scale to handle any documents. And this is done using accuracy, precision, recall, and FN score. So, all the models are evaluated by using these metrics. And to further improve the performance of this project, here we are incorporating principal component analysis. This PCA is used to make the model smarter and faster. So this is used for selecting the most important features of the project, that is most important features of the data. So think of it like picking out the most important pieces of the information from a huge pile of data and ignoring the extra, less useful stuff. So by focusing only on the key features, the system can work more efficiently and make better predictions without getting slowed down by unnecessary details. And here, after picking out the most important features with PCA, the system retains the decision tree algorithm using only those key features, and then it checks how well the new model performs. And finally, it compares the result with the original system to see if by using PCA actually helps. So the goal is to find out whether reducing the amount of data can make the model faster, more accurate, and better at handling new documents, basically making the prediction smarter and more efficient. And moreover, here we are developing a simple web interface by using Flask, and it is also authenticated with the user authentication, where only registered users can log into the system and perform the prediction. Moving on to the implementation. To implement this project, here we have followed the steps which are mentioned in the flow of work. So first, we have imported all the necessary Python libraries, and these include tools for data handling, text processing, visualization, machine learning, and big data processing using Apache Spark. This ensures that all the dependencies are ready for execution. Then comes initializing Spark. So here a Spark session is created and configured. This enables distributed and parallel processing, allowing the system to handle large volumes of CRM related data efficiently. Then comes loading WOS dataset. So the Web of Service dataset containing domain specific research documents is loaded, and the data includes document text, metadata, and domain labels, forming the foundation for analysis and model training. Then comes pre-processing. So the raw text data is clean and standardized. Operations include removing stop words, normalizing the text, and converting it into numerical form that is suitable for machine learning models. And this ensures data consistency and also the quality. Coming to visualization, at this step, the process data is visualized using word clouds, bar charts, and topic maps to provide insights into term frequency, document distribution, and emerging topic clusters. Then comes splitting the data set. So here the data set is divided into training and testing sets. This ensures fair model training and unbiased evaluation, that is evaluation on unseen data. After that, machine learning models are built and trained using the training data. And coming to the front end part, so we have created a simple web interface by using Flask where users will be able to sign up and sign in, and they will be giving the input in the front end that will be pre-processed at the back end. It will be fed to the train model, and the train model will be giving us the output. And coming to the algorithms used, so these are the algorithms used in this project. And to implement this project, we need basically two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview. That is, this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. So these are the source code files of this project. In this folder, we have the data set that is used in this project. So this is the data that is used to train the model, all the models that we have developed. It's opening, just wait for a while. So here we have area, keywords, attribute, and we have abstract of the documents. So this data is used to train the models. Now close it. And this is the test data set that we will be using in the front end for prediction. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap files that are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have the Jupyter Notebook file. So here we have two Jupyter Notebook files, which contains it contains combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have main.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the database file which is used to store the user information. And now to execute this project, we need to double click on this run flash.bat file, which is a Windows batch file. So instead of running this project through command line interface, we have created this Windows batch file. So let's double click on it, click on run. And here if you observe, main.py file has been compiled, and by giving this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is localhost and the port. So after running this main.py file, Flask framework will host the application. So just wait for a while. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So here you can see two options, that is user login and register. So first you need to get registered and then you have to sign in. So I have already registered. I will directly sign in. So click on login here and give your username and the password. Click on login. We have logged in successfully and redirected to this prediction page of this project. So this is the prediction page of this project. If you want to start analysis, you can click on the start analysis or you can click on predict document relationship. So let's click on predict document relationship. And here you can see a button, right, to upload the file. So we need to click on that for uploading the file. And that file should be in the format of CSV or XLS files only. And it should be only up to 10 MB. Maximum, it should be up to 10 MB only. So let's click on it to upload the file. Open the dataset folder. So this is the file that we will be uploading. So select it, click on open. And now click on Start Analysis. So this given file, it will be pre-processed at the backend. It will be fed to the train model and the train model will be giving us a prediction. So here we got the analysis results. So here you can see 70 documents are analyzed. And here 5 categories are found with the 85% of prediction accuracy. And here is the document abstract. And here we have total predicted category. And here for each category that is predicted, we have confidence score also. So the first abstract, it is predicting that it is to be biochemistry document it is. And for the second document, we have ECE predicted. And for the third document, we have medical category predicted. That means this document belongs to the medical category. And this document belongs to the biochemistry block, that is biochemistry category. And this document, it is also biochemistry. This is of medical. And this document is also of medical. And this one is also medical. And here you can see this one is of CS and this is of ECE and this is of biochemistry. So similarly, we have biochemistry and here we have psychology and here we have biochemistry. So here you can see the predictions, right? So you can even download the results if you click on this download. So let's click on this. And here you can see the file has been downloaded. Let's see how it is downloaded. So here we have the document abstract and here, so here we have document abstract and here we have predicted class and here we have predicted category and here we have confidence. So close this. So now let's check with the visualization. So click on visualization and here we have the graphs. So here the first graph, it is the different domains paper published graph. Here in this graph on x-axis we have different papers that have been published which are related to CRM and here on y-axis we have the count of each document. And here we have TSNE visualization of NMF topics graph. And here we have word cloud of each topic. And here we have performance metrics, where on x-axis we have decision tree and on y-axis we have all the metrics scores. And each color represent one type of score. And here we have extension CRM analysis. So this is the different domain papers published graph. And here we have customer segmentation analysis. And here we have word cloud. And here we have ROI and business impact, where on x-axis we have all the models that we have developed and on y-axis we have scores. And each color represent one type of metric. So now click on logout. In this way, just by giving input to the application, that are CRM documents to the application will be predicting the document, that is the category which document belongs to. So if we give a particular document, then it will categorize which type of document it is. It belongs to which concept. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.